Hello everyone, I'm Ted from M31 headquarters, Taiwan. Today, we will be introducing the new generation of embedded USB 5 IP. Our agenda will include the difference between conventional USB 2.05 and the new embedded USB 2, as well as the current IP silicon status of our eUSB2. At last, we will demonstrate several eUSB2 link scenarios with M31 real chips, including critical electrical spec and eUSB host device link. USB standard was announced by the USB-IF in year 2000. It is one of most popular interface used in electrical devices and has influenced human life over 20 years. This includes high-end server, personal computer, tablet, mobile device phone, flash storage, keyboard, mouse. USB is all around our life. Besides data transmission, we also use USB doing battery charge function. M31 starts from 2011. Our first mass production IP is USB 5 in 011 micrometer node. These 10 years, more than 100 products use M31 USB IP, and over 1 billion chips is with M31 USB 5. We are the USB expert. The critical spec is that 3.3 voltage power supply is required in the USB 2.0. However, as the semiconductor manufacturer migrates to a new generation of process nodes, it does not support 3.3 voltage circuit by providing 5 volt, 3.3 volt, 1.8 volt devices like the previous mature node. Advanced node, such as 5 nanometer, 3 nanometer, only provide 1.2 voltage device and no longer have higher voltage devices. Therefore, it is a challenge to implement 3.3 voltage circuit in USB 2.0. Embedded USB 2 is a new generation spec proposed by USB Association in 2018 that extends USB 2.0 spec and use 1.2 volt, 1.0 volt as the interface signals. This not only solves the high voltage limitation of advanced process node, but also significantly reduce power consumption during USB data transmission. Moreover, it is also fully compliant with UTMI Plus interface that used in USB 2.0. It is fantastic. eUSB 2 connection can be divided into native mode and repeater mode. First type, native mode, means both host and device are using eUSB 2 and can be directly use EDP and EDM, the 1.2 signals during data transmission. The second type, repeater mode, represents USB 2.0 connected to the eUSB 2 interface. You have to use repeater chip converting signals, then connect with each other. Repeater is a product that emerged in response to the new generation of eUSB 2 interface. Because not all chips will move to 5 nanometer or 3 nanometer nodes, the widely used USB interface will need the repeater as a bridge to realize the interconnection between eUSB 2 and the conventional USB 2.0. First, we show the critical electrical performance of the M31 eUSB 5. This is the eye diagram of high-speed mode transmitter at 480 megabit per second. Whether its eye height, eye width, or TRTF signaling performance are all in perfect shape. This is really amazing. Secondly, we show the eUSB 2 host connected to a conventional USB 2.0 device via the TI repeater. Host is the M31 5nm eUSB 2 chip, which connects repeater and successfully links to a USB 2 storage device and doing data transmission. On the third, we show USB 2.0 host via repeater chip connects to the M31 5nm eUSB 2 device. The data packet transferred perfectly from one end to the other without any problems. It's very good. Lastly, we demonstrate the native mode of eUSB2. It uses the eUSB2 host and eUSB2 device for direct data transfers. It meets the lowest power consumption requirement of USB links in chip-to-chip interconnections. The next generation eUSB2 will be used in new powerful mobile devices, including 5, 4, 3 nanometer chips, and even for next generation of GAA devices in 2 nanometer. eUSB2 PHY IP developed by M31 has been completed in 7, 5, 4 nanometer process. Meanwhile, the 3 nanometer eUSB2 PHY IP is currently in the process of development and will be available for more advanced application in the near future. And one more, besides low-power eUSB2, M31 also provides USB 4.5 in advanced node to provide complete USB total solution. Thank you for watching. You can follow our Facebook and LinkedIn below. See you soon. Goodbye.